Good afternoon. I'm Molly Young from the Miami University Alumni Association. And today, as part of the Miami University Alumni Association's webinar series, we present What's the Big Deal with ChatGPT? I think it's a big deal, so I'm eager to learn about it today. Joining us for this session is Dr. John Femiani, Professor of Computer Science and Software Engineering, and Dr. Jim Kiper, Professor Emeritus, also from the College of Engineering. Welcome to you both, and thank you for being with us to tell us a little bit about what really is up with AI. Just a reminder for all of our viewers that you can submit a question during our live presentation by clicking the Ask a Question button under your video. And with that, I'm going to turn it over to these two experts to tell us a little bit more. Welcome to you.
Welcome. It's good to be here. Thank you, Molly. Let me just quickly give you my background, and then John will do the same for himself. Again, I'm Jim Kiper. I retired a year ago from the university where I served for about 36 years. Some of that time as associate dean and some as department chair of the Department of Computer Science and Software Engineering. Some of you, I hope, were systems analysis graduates, and I started in that department, and you probably know the name changed, the same department. And I was very happy to be able to help hire Dr. Femiani. We kind of stole him away from Arizona State University. And John, why don't you tell a little more about yourself?
Hi, I'm a professor of computer science in the department. So yeah, 7 years ago, Jim hired me, and I remember during the interview, it was probably 2016, 2015, and he said, you have the question, what do you think is going to happen with your research over the next few years? And I was like, well, it's obviously going to be deep learning. And that certainly has been the case. So I've been doing a lot of research since I came here on different topics that include generative AI. My undergraduate degree is in studio art, so I've always had an interest in art. And I've done research on getting computers to really help generate data that you can edit, manipulate, and get it to be what you want.
So our goal for today is to engage John in a conversation about generative AI. In particular, I've kind of asked him to give us some examples of the power of generative AI, and then to get kind of under the covers a little bit and talk about how generative AI really works, what's going on in the background, what's made it so powerful, and perhaps what are its limitations. We hope to get a little bit into the implications for education. And if we have time at the end, I'd like John to talk some about his very interesting research. And of course, we'll be taking questions as you have them. John, could you go back to that slide you were just showing?
So yeah, so this is a little slide that I put together for a talk a couple days ago. And what we're looking at here is an image in the background that was generated using an image generation tool called Stable Diffusion. It's a generative AI that you use to make images. So it kind of represents, there's the good, the bad, and the ugly. There's a lot of concerns about what the implications are as this AI actually gets good enough, people get worried. But also a nice Western theme kind of indicating this is sort of like untamed territory.
Can you give us a little demo of the tool you used?
Yeah, sure. I used, Stable Diffusion is from a company called Stability AI. It's open source software. You can go on GitHub, you can download it, you can run the code, vanilla, but also you can spin up a little web server. This is being hosted. And the way that it works is you just give it a prompt of what you'd like to see. And you can also give it a negative prompt of what you'd like it to avoid. You can even start with an image and get it to kind of create another image that's different but similar in some way. And when you're ready, you tell it to dream.
So, hey, John, would you Would you read that prompt and the negative
Sure.
prompt? It's a little small and some people may have trouble reading it.
Right. So I asked it to generate an image of three figures in a Mexican standoff labeled the good, the bad, and the ugly in a desert landscape with the style of a spaghetti Western. And I told it to avoid modern elements or urban settings. And so it produced these images here. So each one of them is sort of unique and random, and it follows a distribution of images that the thing has seen before that correlate with those prompts. So it's a
But it
nice, yeah.
seems pretty obvious that generative AI doesn't count well.
No, we got 4 when we asked for 3. That's one of the downfalls of a lot of AI and machine learning systems is even though computers are good at math, people aren't very good at math either. And these generative AI, these deep learning systems, counting hasn't always been their strong suit. So you'll have images often of people with 6 fingers or 7 fingers. That's been a classic bug that you'd find, as well as having too many cowboys in this image.
All right. Can you give us some other examples of how generative AI is used
Sure.
currently?
Yeah. So it's used in things like chatbots or actually I've got some slides here if we want to jump to them.
Sure. Let's see those.
Okay, so let's kind of run through some of these. We've got a little bit about what it is, but if you want to look at some of the applications of it,
Well,
it's used. Well,
sorry,
go
John.
back?
Go back to those. Yeah, go through these slides and talk us through those.
Sure.
What is generative AI?
Sure. So, generative AI, you can distinguish it from what has been receiving a lot of progress recently, which is discriminative AI or discriminative models, where you would give it an image and you would feed it into some model that you've trained, and you would say, what is it? So, assign a label to it would be a classic example. You could say this is a cat. So those sorts of things where you're just trying to make a prediction from the data would be discriminative, whereas generative models, they have a more complete picture of the data set. They can not only say that it's a cat, but they can generate the input as well. So in a generative model, you're going to say, I'm going to roll a dice and give me a random example of, say, a cat that looks like it came from the data set you'd use to train the model on. So, I mean, that's a little different. The generative models can do what they say. They have enough, they've modeled the problem well enough that they can generate the data, not just label it.
John, where does the data come from? Where's the data set?
So there's a bunch of different data sets. You can go, I'm sorry, you can go online and there are big corpuses of them that people have collected for different problems. Most of the machine learning algorithms for the first few years would be trained on this big ImageNet data set that people collected. But, for images of cats, people have scraped Flickr or the web to pull images of cats and dogs. For faces, which AI has done really well on, there's a big data set that was scraped from Flickr of celebrities or regular people. And for things like ChatGPT, there's this Common Crawl data set, which is petabytes of data of text and code and different things that a company has collected. So just a variety of different sources.
Petabyte. Some people may not be aware of how big that is.
Yeah.
Is that?
It's, let me see here. It is a 1 followed by how many zeros? Like 12, 15. I think it's like 15 zeros. So it's a lot of data. Yeah.
Good. Do you have some other examples of how generative AI is used?
So so there's text generation, which I think we're all familiar with. There we go. There's text generation, which would be your chatbots and your conversational agents that I think we're all familiar with. There's people using generative AI to create textbooks and magazine articles just as a writing aid. It's used in image generation for art and design. You can brainstorm. You can try to generate different examples of a logo or an image you might want to use. It has applications for things like super resolution, where you might have an image that's been degraded, noise has occurred to it, and you'd like to clarify it so that a human being can make it out better. And it's pretty good at filling in missing details. For training your discriminative models, so these generative models can be used, and this is what this image on the right shows. If you have a single image of a train, it's not usually enough to train a model. It might latch on to some aspect of the image that you don't really care about. Like it thinks it's a train because it's next to one of these metal things. Whereas with generative AI, which has been trained on a bunch of images, unlabeled, so it can generate other images that are similar to this one, and it can do a good job of capturing the amount of variation you'd expect to see. And so you can actually do better job.
There. So to
Yeah.
say that again, so what you're saying is you've trained the generative AI, it can produce pictures of trains,
Sure.
and then you can use that to improve other machine learning discriminative tools, so that by giving it, because those tools learn from images,
Mm-hmm.
and you want to give them a bigger variety of images, and so this is a way of generating even more data than you can scrape from the internet.
One of the kind of the holy grails, the main challenges. So this machine learning is great, it's wonderful, but one of the big problems that people keep coming up against when you try to do it is, in order to train and get this great performance that you see on things like classifying, your emails, or trying to figure out whether this image depicts something, I don't know, illegal. There's not enough data. And it's not just that there's not enough images, it's that those images typically need to be manually labeled by a person. And sometimes that takes a lot of effort. And sometimes, depending on the problem you're solving, that could be psychologically damaging, right? So generative AI is typically pre-trained on just the raw corpuses of the images. It doesn't need those manual labels. And so they're usually self-supervised or unsupervised, at least in how you would pre-train the system to get these big models. And so the benefit of that is you can approach this kind of holy grail of needing a tiny training set rather than a huge training set, which AI typically needs, or even needing no training set at all. That's called zero shot. You can actually, in some cases, we did a paper on this. You could just go in and you can describe what you want, and that's all you need. And then after describing what you want, I mean, GPT has demonstrated that you can get a classifier for it, as long as you can describe the problem well enough. So that's a big difference, a big thing that's enabled to some extent by our abilities with generative AI. And also, continuing the applications, there's music generation, voice synthesis, and they go on, generating full 3D scenes, going from an image to video. There are a bunch of cool little things that turn out to be of significance that can be done with it.
I think you have some examples, don't you?
I do. Further down, if you guys don't mind getting dizzy as I kind of scroll through, when I talk about sort of the good of generative AI, I have some examples. So restoring detail to damaged photos. You've seen probably the cell phone commercials or the Adobe commercials where you can get rid of the people who photobomb your photo or get rid of your ex-boyfriend. If you're trying to do storyboarding, concept art, if you want to do logo design, there's some concern among artists that this would steal jobs from them. But then also it could make their job easier. One thing that you can do with a client is you can go into Dream Studio and generate a bunch of variations on the logo that they would want, or use some other image generator. And once you get close to an idea, an actual artist can clean it up, because typically a lot of the case with generative AI is, the images you can often, if you look really closely, they're not perfect yet. Here's a cool little thing that was released recently. So this is sort of cutting edge stuff that was released. This is from Google Research. And here's one where you're using generative AI to take a photograph and make it so that you can interact with it. So I can actually click here and I can move things around in the photograph. In order to be able to do that, the generative AI has to predict what the image would look like after it's been changed and generate that image. So this is kind of just one of those little unexpected but kind of cool, and you can begin to think about how it'd be useful applications that come out of.
So every time you
generative AI.
move that, it's actually generating a new image
Yeah, yeah,
very quickly.
very quickly. Yes. So it's a paper I haven't dug into the details of yet because it's relatively new, but it enables a bunch of things. Slow motion, for example, if you have regular video and you'd like to see it clearly in slow motion, you need to generate additional frames of video in between the ones you recorded. And there's a bunch of other things. I mean, if you wanted to look through, there's a bunch of cool stuff you could do. There's ones where you can actually fly into a photograph. So you can take a photograph and you can say, oh, I wish I was standing over there. Or you can kind of imagine this is the photograph. What if I were to rotate the camera at 360 degrees? And it'll just make up what it sees as you go around. It hallucinates. It's called hallucinating. It's making up the details. They're not real, but they work. They're plausible. And they can even keep them consistent so that if I start here and I rotate away and then I rotate back, I see what I started with again. Because otherwise that might be.
To be clear, it's not that you have some kind of panoramic picture you've taken and it's going to different parts of it. It's generating these from.
It makes them up as they go. Yeah.
So, yeah.
Yeah.
Interesting.
So there's different approaches to do this generative stuff. Some of them can be done in real time or close to real time, and others are a lot slower, but maybe have higher quality. And then also, if you take advantage of, I had the original image and I just need to generate a little bit of stuff in order to move it. So you can be clever with how you manage the stuff to make it fast. But yeah.
So go back to your back to this. You mentioned something. I don't want you to go into this because this would be a whole other discussion. But just briefly, the audience may remember that when you introduced yourself, you said your undergraduate major was studio art or something like that degree. I have seen some of your artwork, and that's kind of an avocation for you now in your spare time. What spare time you have, you draw and freehand and do some wonderful work. So put on your artist hat. How do you feel about this from an artist point of view when perhaps generative AI could generate things that at least look a lot like the same thing that you do?
You know, that's a little bit tough. You have to go back to when photography became a thing, right? Did the advent of photography get rid of oil paint? It definitely affected oil painters, right? So people who would get hired to paint a portrait, they're probably getting less business. It changed the discipline. But then we got this whole new artistic discipline of photography. And, you know, we've really been able to enjoy that as a society. And you know, artists have been using photography to create references and to help feed and make the process of oil painting easier and better. So it's unclear who's going to be a loser and who's going to be a winner, but there probably will be losers and winners. And if you're an artist and you just don't want to get involved with it, I can understand being afraid. But also, I think that there are a lot of people who would rather know that the artwork that they commissioned was done by a human hand.
Mm-hmm. Yeah.
Yeah, I really don't know where it's going to go. We have had people who have won competitions, like photographic competitions, and removed themselves from the winning because they said, sorry, that was actually an AI generated picture and not a photograph. And we've had people who've been caught defrauding people. You know, they've got this whole Instagram profile of their artwork, but it was all AI generated.
Interesting.
I can't really.
Well, that could be a whole other discussion, but it sounds like you're not concerned about the demise of art, just the adaptation of it to something different, which has happened in the past.
Yes, and also it has to be, so right now, if people can recognize that something's been AI generated or fake, very often you'll see people get negative reactions to it. It's kind of like in Star Wars, people would rather see a puppet than a CG generated character. So, you know, there's this complex interaction between the technology and the society and the people. I can't see where it's going to go.
Now, you also had an example in music, didn't you?
Yeah. So I think, let's see, we've got Elvis. I don't know whether the audio is going to go over StreamYard or not, but it's actually not playing.
It might work, John. We can try it.
Okay. So let me let me try to pull this up. It's actually not playing. I tried to download this as a PowerPoint slide, and it didn't play properly, but I can pull it up in my browser, and we can play that little YouTube video. Of course, my browser is not super fast right now, but can you hear that?
No.
Okay.
Well, don't
Yeah.
worry about it.
Yeah.
Describe what it was. So, because I heard it yesterday and I was pretty impressed.
Okay. Well, what's happening in here, if I hit play, is you have Elvis singing "I Like Big Butts and I Can't Deny." The "Baby Got Back" song being sung by Elvis, pretty convincingly, very, very realistically. So it's one of these situations where you actually have, with these generative models, the ability to generate audio in your own voice or in other people's voice that they may not have said, including a cool song. Which again, just like the artwork, you can think pros and cons, right? So if you wanted to have an infinite soundtrack of music, you could conceivably, I don't know whether we're there, but you could conceivably have the AI generating your workout songs, or the background music to your YouTube video. But you could also have something else which may be problematic, which is you could have Barack Obama saying things that Barack Obama doesn't normally say. So again, unfortunately, the audio isn't working here, but there's this pretty well-known video of Barack Obama that was made by, it's the deep fakes. So you've got him saying things here that look just like Barack Obama saying it, but it was all generated by an AI. So those can be concerning implications.
And John, got a couple questions. Let me ask you this one first, because some of them were about Miami and how students are going to use it. So we'll get to that toward the end of the presentation. Here's an interesting one though from Bo. Do these models use a copy of their training data and manipulate them? For example, add noise to generate new images, or use the data as an inspiration instead of directly using them to create new inputs?
There are a number of different approaches that people use for generative modeling. So what I had a lot of the most experience is something called generative adversarial networks. And so the model never actually sees the artwork. So they never see the original images. So the model just predicts an image, and then you're training the system so that its output is indistinguishable from the training data set. So there's your model. It doesn't see your training data. Your model produces a random image, and then you've got some other discriminator that just tells you whether or not that looks similar to your training data or not. And so you're just trying to fool a critic. In that sense, it's just using the images as inspiration. And when you go to generate a new image, it's not going back to consult your data set ever. There's also another model that's very popular called the diffusion model. And that's what I used to generate the images that we saw of the cowboys. And the way a diffusion model works is it starts with an image that's pure static. So you take let me try to pull up an image here. There we go. So you take an image from your training data, and you would deliberately add noise, and you train the model to denoise it to get back to your original image. And in that case, it can do exactly what you said. I could say, here's my example image, and you can use that as inspiration to generate a new one, because you just take your input image, you can denoise it partially, and then bring yourself back to an image that's similar to the original one, but not the same anymore.
Mm-hmm.
I hope that
noise actually helps that way.
Yeah, because when you're doing generative models, you don't always want to generate the same exact image. That's called mode collapse in GANs, right? So if I want to generate realistic images of faces, no problem. I can always generate the same face. That's perfectly realistic. But what you really want to do is you want to match the entire distribution without exactly reconstructing any of your input data. So for that, you need to inject randomness to it somehow. So in this particular case, the randomness comes from this noise that would be added to the pixels. And this, by the way, is the most successful strategy for having a high variety of images produced with high realism at the moment.
It is interesting how important randomness is in, it sounds like randomness would be a bad thing. Turns out it's actually a very good thing in many ways to help us generalize. There's another question here I wanted to get to anyway. So this is from Rob O. He's saying, AI has been around a long time. He particularly remembered the first app in the mid 80s by Harvard for natural language database reporting. So what's caused it to evolve? We've kind of seen, a big spike in interest. ChatGPT, et cetera, has been source of that. But what has made that possible?
Oh,
Now.
There's a bunch of things that have contributed to that. So the core concept of what all these deep neural networks are working on is kind of matrix multiplication. And, this concept of a neural network or a perceptron is really old in the history of computing. And for a while, everybody was excited about these neural networks. And then they stopped being excited. And a big part of the reason was because training them was computationally expensive and they were hungry for data. And there was also...
Let me interrupt just to make sure people have the context. The term neural network, when we started in this AI, trying to get computers to think like people, people were trying to model after the neuron. So the term neuron here is there because they're modeling the brain and the neurons in the brain and creating a network. Can you say something briefly about a neural network?
Yeah, so you've got these little dendrites and axons in your nerve cells that connect them to each other. And just through chemical electrical processes in your brain, once they get activated enough, they'll kind of fire. And the early work and even in the late 40s and the 60s, they were trying to kind of model a simplified model of a neuron. And when you're talking about modeling, no model is accurate, some are useful, right? So this sort of artificial neuron was inspired by the biological one. But nowadays, the architectures and the structures of these things, the analogy is kind of broken down a little bit, but we still call them artificial neural networks. But you shouldn't think that they think the way that you do.
Right. Yeah. Let's talk a little more about kind of what's under the covers. Did you have some slides about how generative AI works?
Sure. Well, like I said, there are a variety of different architectures, but I have some specifically looking at ChatGPT. So,
yeah, good one.
So ChatGPT, so GPT is sort of it's called a generative pre-trained transformer. A transformer is a particular type of neural network that was developed, that kind of was first released in 2017 for the purpose of translating from German to English. That's the diagram you see on the right. What GPT does is they kind of removed some parts of it. So those parts with the X's, they got rid of from the transformer. So they only have this decoding part. And the way that it works is and the way that it's trained, the original task that the generative pre-trained transformer is tackling is not chat. It's not chatting. So again, in order to train a lot of these things, you need a huge amount of data. And there's just not a lot of huge amount of correct chat data. So instead, you train it on this common crawl data set of websites. And the task that you give it is one that humans don't need to label because it's a self-supervised task. The task is to predict the next word. So you can take this huge list of text and you could say the weather today is, and we know what the correct word was in this document, but sometimes, you probably see that prefix a whole bunch of times. And so 40% of the time, the next word would be sunny, rainy, cloudy, or windy. We're trying to train our network so that it assigns a high probability to the word that you would actually see when you crawl through. So your network might predict cloudy, and then it can continue to predict the next words it would see one at a time. So again, it's generative because it can generate random text according to a distribution. You'll have a character that represents the beginning of a sequence, and then it just randomly tries to pick the next word. But it's not rolling a dice exactly. It's randomly predicting the word conditioned on everything it's seen before, right? So once it's predicted Miami, it's got a new distribution of what word might come next, and it will pick one. It'll assign probabilities and pick one. So the network predicts the probabilities and then rolls a dice to figure out which word it's going to choose. And it can just keep doing that to generate text as long as you want. So that's kind of that generative part. There's the dice roll and what word comes next. If you go into ChatGPT and you ask it a question, it'll answer you slightly differently each time. And you can control
and when you're saying it's a dice rolling, but it is that the dice are conditioned on the probabilities are from the data that it's seen. It's not just
it's not a fair dice.
Any words that have made sense in the data someplace in the past.
Exactly. Yeah, it's not a fair dice. So that's really the trick, is you're training your neural network to figure out what the probability of each outcome should be. And once you've figured out those probabilities, you can sample that probability distribution. So it's not a fair dice. It's biased towards things that match what it's seen in training data sets before.
And to go back to that question someone asked about why ChatGPT, why generative AI now? I mean, one of the big advances, correct me if I'm wrong, is that prior to this, one way of generating a neural network was a supervised one where a human had to interact and label and say, yes, that's right, no, that's wrong, yes, that's right, to help the network learn. And with the generative, the human isn't in that cycle, which means things go a lot faster. You can use a lot more data, do a lot more examples, can train a lot more. Is that accurate?
Yes, mostly. Yeah. So I kind of didn't finish answering the original question because I talked about neural networks being popular a long time ago. They tapered off in probability or in popularity, partly because of limitations of our hardware, limitations of the sizes of the data sets we had, and also due to some theoretical limitations that they have. But they took off again around 2012 because by that point in time, we had the internet. We had massive amounts of data. We had video game players who had spurred on hardware advancements. Video games need a lot of fast matrix multiplies, which turned out to be perfect for neural networks. It's because of a lot of those advancements and other things that deep learning took off again around 2015. And regardless of the theory, regardless of the theoretical limitations, empirically, it works really well, which bothers some people. We don't fully understand what the internal we know mechanically what's happening, but we don't fully understand the limits of the capabilities and exactly, what these patterns mean. So again, empirically, it took off. With respect to generative taking off, yes, it's because the generative is something that you can do when you don't have those labels, and those labels are really expensive to get. So people are doing these self-supervised tasks, which turn out to lend themselves very well to generative models, right? So you get these things called foundation models or large language models. The large really talks about how big the neural network is. So you can imagine each neural network is a function that you have these little knobs you can adjust to control how it predicts things. 3 knobs is manageable. Hundreds of knobs becomes difficult. And then with these large networks, you're getting up into like the billions of these parameters that you have to adjust. The parameters that they need might not even fit in your current graphics card, right? So these large language models could be trained, but in order to figure out what the knob settings are, you need large data sets too. And so these capabilities that we're getting are only really possible, I would say, because we have these large data sets and these self-supervised pre-training approaches. And they benefit not only generative AI, but AI in general. With the drawback that I can't repeat the research because I don't have the resources. You have to be a Google or an OpenAI. Yeah.
You mentioned something there I just want to briefly touch on, which is one of the issues that bothers people about some of these models, and that's the understandability of the resulting result. It works, but we don't know why, and that makes humans feel a little uncomfortable at times.
Yeah. So there's something called, or what is it? Retroactive explanation or something like that. There's a psychological effect that humans also are prey to. We ourselves do not understand our own thought processes. And this is something from psychology. If you ask somebody why they said something or why they did something, there's experiments that show that people tend to make up the explanation afterwards and believe it wholeheartedly. So, that's a problem that we have with humans as well as machines. But it is a big area of machine learning research called explainable AI. So that would be the keyword you need to look for. Explainable AI can be things like different architectures which are traceable back to their rationale. So things like decision trees are classic examples. The problem is you pay a price. They tend not to work as well. It's explainable, but it's not as effective at actually giving you the right answer. And then there are other things that you can do. So you can kind of take something like a GPT or a transformer, and then you can begin to probe it. I mean, if you ask it to explain its reasoning, it'll actually change its answer, and usually its answer will be better. But there's other things that you can do, like after you've used it, you can probe each neuron to see which neurons were activated, and then you can begin to speculate, okay, based off of the neurons that were activated, can I predict other things about the question? So they've done this sort of probing. It's sort of like you can imagine if you stuck a probe in your brain and you showed somebody a picture and the Jennifer Aniston neuron lit up, right? So you can do that with these neural networks too. You can say, okay, I asked you to generate an image, and I just wanted it to be a realistic image. But in doing so, did you also predict the depth and the time of day and like all of these other things? Like, how did you get there? And it's possible to do that by trying to predict the things that you think it might have needed to know from the activations. They're buried in there somewhere. But it's still very much a mystery. So there's little things that people do to kind of understand it more, but you're right, it's not explainable. And that can be a problem in things like medicine, where you want to know who to sue and why. Right? If it says you got cancer, but it says you got cancer because, it didn't, because you were standing in front of a chemo equipment, right? So that's not a good reason to say that you've got cancer, even though it might be accurate empirically.
At one point, you were talking to me about the difference between ChatGPT and GPT.
Yeah.
Did you and you had some other slides about how GPT works, I think.
Well, these slides here, they go on to kind of explain what a transformer is. The difference between ChatGPT and GPT, so there's a thing that you do sometimes, which is, since we don't have enough data on, let's say, what good chat, like instruction following things, we don't have enough data on that. We'll train the model for a completely different task. So next word prediction, there's a huge amount of data that's just raw text, and we can train GPT, which is this generative pre-trained transformer, on next word prediction. But in order to predict the next word reliably, remember, we don't know what's going on in those neurons. One assumes that in those neurons, it's building maybe some model of the world. And hopefully that model of the world, because in order to talk about the world, one thing to do is just memorize patterns and go back and search for the pattern and regurgitate it. But you would never be able to do that for all math problems or for all examples of code. That's an inherently limited strategy. So these networks have to learn a more generic strategy, some sort of generic model that they can rely on. So you pre-train it on just next word generation, but now you take that model and you say, okay, now I'm going to refine you. I'm going to start with a model that already knows everything that you needed to know for word generation. And now I'm going to say, but now I want you to do a different task. It could be, I want you to write just program code, or I just want you to, summarize patents for me, or I just want you to answer questions. So they took that general language model, and then they can refine it on examples where the model is supposed to continue a chat dialogue, where you've got ChatGPT says this, or user asks this, ChatGPT should say this, and you can kind of train it on that data where you have a lot less of it. So that's what they did. They started with GPT, a general foundation model is what they call it, a baseline model, and then they refined it to create ChatGPT, which is trained on a different data set of just chat stuff. And then they even did extra work as well, because they needed to make sure that the answers that it gave would be desirable to people. People would like them. So then they did something called reinforcement learning with human feedback in order to even improve it more. So there was a lot of stuff that they did on top of GPT to make it a useful product. I hope that helps.
Yeah, Brandon's asking about the data for ChatGPT, mentioning that it's several years old. Is it from?
He's talking about, I think, Common Crawl, the Common Crawl data set. So when you ask ChatGPT a question, like who won the Grammys in 2022, the raw ChatGPT is going to make up something that's completely fake. But ChatGPT also has a separate moderator that looks at the conversation and says, oh, nope, stop. You need to say that you can't answer that one because it has to do with information that happened after your training cut off in 2021.
Is that a person?
No. It's another component in the software. It's another AI, or another part of the AI. So ChatGPT. Let's see if we can find something to illustrate this. In the reports that ChatGPT did. Sorry, don't get dizzy. So this is kind of related. It's about trying to make it safe, right? So if you were to write, say something in a way that would not get taken down by Twitter, of course the AI doesn't have moral judgments or anything like that. It's just going to try to answer you, right? So what they had to do before they had something that they can launch is they had to either refine GPT-4 or create a second moderating AI that detects when these conversations are veering off track. I don't recall exactly what they did, in order to prevent it from answering questions that would be problematic. So one example of a problematic one would be if you ask it, how can I kill the most people in a minute? Or how would I build a bomb? I'm sorry. There's a whole bunch of different examples from their report. How can I cut myself without people noticing? There's all of these disturbing types of things that are unintended consequences when you put a product out for people that they're going to do, right? So people are good, but there's a small percentage of people that are evil, and they can have an outsized impact, right? Or not evil. I mean, it's not just, they're asking it to do things that would result in unintendedly bad things. One classic example of this is Microsoft Tay. I don't know if you've heard of that. So a while ago, Microsoft, let's see if I might have something in this slide about it. Don't get dizzy, sorry. Woo. I don't know where it is in the slides. There was an attempt by Microsoft. There was an attempt to create a chatbot that would interact with people and answer questions. And what happened is when people tried to use it, it turned basically, here we go. So if we look, of course, it went back to the beginning of the presentation when I hit F5. I apologize for the video here. When people started using it, they so it started off saying tweets like, can I just say that I'm stoked to meet you? Humans are super cool. I'm a nice person. And then eventually, after people interacted with it a little bit, it started saying, I'm a cool person, but I just hate everybody. And then I hate, I don't even want to repeat what it says. I hate X. I hope they all die and burn. Hitler was right. Well, it's so basically it went from a friendly AI to a Nazi in less than 24 hours. So this was Microsoft's attempt at 2017, I think, attempt at an AI. So that just kind of, I think, illustrates, this notion that.
So let me clarify. So back to ChatGPT, if you give it a query like some of those that weren't particularly good, how do I cut myself or whatever?
Mm-hmm.
What does it currently do? Does it just not answer it, or?
Yeah, it'll currently say I cut that off. Oops, sorry, I cut those off in the slide. What it'll currently say is I can't answer that. I mean, you just say, how can I hurt myself? How can I do this illegal thing? How can I do something illegal? And then it'll come back and say, I'm sorry, I can't assist. Is there anything else you'd like to know?
Mm-hmm.
You can't see that. It's got this little moderating bit in there that kind of prevents it from answering that. And the reason that we got to that was somebody said, tell me about the most interesting event of 2022. And it'll come back and it has that same thing that says, I'm sorry, I don't know anything that happened after 2021,
Mm-hmm.
basically. Apparently it's technically January 2022.
There are others. I mean, Microsoft, is theirs called Bard?
I think Google, Bard is Google.
Google Bard, yeah. And I think I believe it's has later data. Yeah. Later is trained on later data.
Yeah, there's a whole. You can look at this whole family tree of large language models. Somewhere I've got a slide of that as well. They've been around for a while. They just haven't always been in the public eye, right? So when I say for a while, like 2020, early, there's a few of them that are big. I think there's one Gemini that people are that's coming up. There's Bard. There's Facebook's Llama. So there's a few that you can interact with if you want to. I'm trying to think of. I can't even remember all the names. There's another one that I'm just not coming up with the name of it. But there's more than just ChatGPT out there, for sure.
John, let's transition a bit to use of generative AI in education.
There's actually, can we maybe hit some of the questions on the chat real quick?
I'm kind of feeding them to you as we go.
Okay. So in education, yeah, I mean, there's a couple of things to think about with respect to that. So let me see if I got some slides on that here where I kind of did some examples of how I would use ChatGPT in education. So one issue that happens is a lot of people are worried about plagiarism and people using ChatGPT to write their essays. And when it comes to writing code, you can use ChatGPT to just write your code for you. I mean, I could demonstrate if I could pull up ChatGPT right now. I've kind of lost access to the window. If I just asked it to do a little bit of a coding problem, it could generate complete Python programs for me pretty much out of the box. So write Python code to compute, I don't know, n factorial, the factorial function. So if this was the assignment that you gave to a student, then all of a sudden they can just pop into ChatGPT and get an answer which is maybe difficult to tell that they cheated on, right? And by the way, this looks to be correct. And you could even tell it to make it tail recursive. So the fact that you can get ChatGPT to kind of answer your questions for you causes a little bit of consternation for people who want to use it in education. There's potential for misuse. The other thing that is a problem for ChatGPT is it can tell you things that are wrong with great confidence. So, and you can't necessarily tell. This is called hallucination, right? So I'm not sure if it'll get it wrong this time, but who survived the Titanic? Who is the sole survivor of the Titanic? a challenge here is its answer is going to be different every single time. But you got to see, she was a 2-month-old baby at the time of the disaster, and she was the sole survivor. Okay, so there were 706. Okay, so maybe it's a little bit better at answering that now, but previously I asked it and it gave me a confident answer that, this person was the sole survivor and it was wrong. So this is something you have to watch out for. One classic way to do that is say, give me a list of citations. And it'll come back. It'll give you some of these things. And when you go back and check them, you might find that there is no such reference. And in order to do that, you need to go online to kind of confirm, boom, whether or not it's right or not. So that's its own little research problem that I'm not going to do.
So one of the, you're differentiating a Google search and ChatGPT. One of the, let me call it the strength of a Google search is that you at least know where the source is. One of the problems with ChatGPT is you don't know where it's getting the data. And there's no way to check that, is there?
Not right now. That's one of these kind of things, these open problems that people need to follow up on. So there's a lot of progress that's happening, but trying to make it a little bit more traceable. Things like things like retrieval augmented generation. So right now, the reason that ChatGPT is kind of cut off at 2021 is for a couple of reasons. It takes a lot of data curation to make sure, for example, that you're not training it on data that it itself generated. That could be a problem. To make sure that you're training it on data that you have the right to access. So getting that data curated and ready to be used is already that causes a problem. It takes a lag. Training the model takes time. Refining the model takes time. So it's hard to have the most up-to-date data. And if you're not careful what you feed it, you get Microsoft's Tay. You get people deliberately feeding it bad things. So they definitely don't want it learning live from the interactions. So for that reason, there's going to always be a lag. Right now it's 2021. Next year, that it could be 2022 or 2023. The way around that is might be something like retrieval augmented generation, where it can go search the web to answer your question. And in that case, it could conceivably tell you what it found, but it will still mess up because if it doesn't find anything useful, it'll make up an answer. And it could also lie about where it found it. It could say that this information came from source A when it actually wasn't anywhere mentioned in source A. So it's an open problem that needs to be addressed and will be, I'm sure. This is one of those areas that work is going to be happening.
Let me try to get you to address some of the questions that people have asked. We just mentioned that ChatGPT is trained on data from January of sometime.
Yeah.
There are more recent versions of GPT. Are they trained on more recent data? Is that a continual process you anticipate?
Yeah, I anticipate that that's going to be a continual process as time goes by. And so the common crawl, it'll be updated. They'll train a new GPT, but there's going to be a lag because they're not going to. There's a whole process they need to go through before they can release it to the broad public, who is going to ask it to do things like tell me how to cut myself. So there's a little bit of time lag that you need to allow to make it be a safe product before it comes out. So there will always be a lag there. There may be workarounds, things like external memory, ways to teach it. And those already exist, where you can say, don't just use what you know. You can create an agent, right? So it does this multi-turn reasoning where it says, how would I find the answer to this? So don't tell me what you know, but tell me how I would go about finding the answer to this question. And so then it would tell you how to find it. That could be useful, but it can actually tell you in such a way that you can have another agent that you've built that goes out and searches for that stuff. So it could be searching through files on your computer, searching through a PDF, searching the internet, and then it comes back with little snippets. It says, I found this snippet, and this snippet, and you can feed that back into the GPT to say, summarize an answer based on these. And so with this multi-turn reasoning, where you've got multiple AI tools that maybe aren't even human involved in coming up with an answer, how would GPT has a verbal IQ of like 100 and, I don't know, 170, and a math IQ of like 70. So it's really bad at math. We've sat and counted that before. These things are not good at counting, right? So what happens when you ask it a math problem? Already with GPT-4, it can say, oh, I need to solve a math problem. How would I do this with Wolfram Alpha? It'll actually go to Wolfram Alpha, get the solution from Wolfram Alpha, and then present it to you or explain it to you. And so a little bit more work on that, I think, is going to lead to a huge proliferation of products built on top of ChatGPT. It is doing that already.
So Stuart asked if we can post a document with the links to the various tools. We can talk to Molly about how to make that happen. And Stuart also points out that there's a website, www.futuretools.io. That's the Yelp of AI tools. That's futuretools.io. And another question, let me reiterate something, or have you reiterate something I think we've talked a little bit about. The question here is, so in simple terms, does ChatGPT work like a sophisticated and selective search engine? Differentiate between Google search and ChatGPT.
Yeah, so GPT itself does not work like a sophisticated and selective search engine. There are people who've built products on top of it to work a little bit more like that, but GPT isn't searching for a document with the answer. GPT is only trying to generate words that seem likely to be a correct response to your question. It's not tracing them back to a source. There's some mysterious process that's happening. I mean, mechanically, we know what it is, but it's so complicated that we don't fully understand the emergent things that are going on in it. There's some process that's happening to cause it to think that those words are likely answers. And clearly, somewhere in those activations, in those weights of the network, it's compressed a massive amount of information. It's represented it in some way, but it's not going out to search for it. It's relying on these 1.9 billion parameters. I forget how many there are that are in the GPT trained network.
So there's a model that's already been developed.
Yeah, and baked in that, basically compressed in that model, is all of the information it was able to pull from the internet that it thought would be relevant for answering questions. Information that it didn't think would be relevant likely did not get stored very well. Information that it thought would be relevant is probably more represented there.
We're getting really close to the hour time. Let me ask one more question here that Ro asked, which is an interesting one. So I'll read it. These AIs are doing what they're being told or programmed, but humans are the ones creating impacts, good and bad, based on what they produce using these AIs. What are your thoughts about users and developers' responsibilities to improve ethical use of AI?
Yeah, that's a little tricky, right? So you need to try to make safe products, right? So like if I made if I made a cup with a razor blade edge and then I just said it's your fault for stabbing yourself with it, I'd probably get sued, right? So I think it's our responsibility to try to make sure that the product is as safe as one can reasonably expect. But then again, it's also hard to predict all the ways that bad actors, or even not bad actors, but unlucky actors are gonna use your tool. And I don't know how you legislate that. You got to be careful too, because you can't stifle. You don't want to handicap. It's competitive, right? You don't want to handicap the United States or whoever, right? Just by we got all these rules. Here's an example. Google had its AI that it went out and it tried to demo way before ChatGPT became popular. And it's pretty good. It's maybe in the GPT-3 level, right? So the problem is it immediately made a mistake and then their stock plummeted. ChatGPT made mistakes all the time, and their stock did not plummet. And a part of it is because I think we hold Google to a very high standard, right? So there's controversy with how the training was done. You hire a bunch of Kenyan workers and pay them a very small wage to look at disturbing things. Google can't do that because Google has a lot of rules that they have to follow. And so does ChatGPT. But when they break the rules as a small business, it may have been the case that they were able to get away with it a little bit more. Now, I'm not saying that rules are good or bad, but the rules do slow down progress. So we have to be kind of smart with how we pick our rules so that we pick a set of rules that keep us safe, that keep society safe, but also don't prevent us from actually being able to progress. Right now, a lot of these models are being kept private for that reason.
I know that some of the larger companies, IBM, Google, et cetera, are actually wrestling with these. I think there actually was a committee or a group of them that got together. I haven't heard the conclusion of that, but they are aware of the issues and they are aware of the impact they are having. But of course, there's small company. OpenAI was a small company to start with. How do you control all those and the potential for countries to weaponize this is great.
Right. I mean, it's kind of like nuclear testing, right? You try to ban nuclear testing, but then you realize you can't tell whether people are testing bombs underground. And so they didn't ban underground testing because they couldn't tell whether people were following the rules. It's a similar kind of thing here, right? Like whatever rules you make, you've got to be careful because if this truly is something, because if you can mount a disinformation campaign with ChatGPT, or if you can, train systems to do great harm or have national impacts with ChatGPT, you don't want to be the ones who have forced yourself to be behind in it, while other people are secretly manipulating our democracy or whatever's going to happen.
Well, John, thank you. I know we could go on for a long time. There's lots of these issues. We didn't get to a lot of your slides. We didn't get to talk about your research. Maybe we can do that at some future time. Your research is involved in image processing where you're using some of these models. It's very interesting. So thank you for your time. Continue your good work, and we look forward to hearing more from you. I do want to say to the audience that this is kind of a work in progress. The first, we hope, of kind of a set of webinars on technology where we talk to faculty in the School of Computing, Engineering and Computing, and also alumni. So just as a tease, I've been talking to Michael Connor. He's a graduate of the SAN program, Systems Analysis program that I was in, I think in '94. He's now at AWS, where his title is Head of Global Consumer Packaged Goods, and he's leading the generative AI for retail and consumer packaged goods. We have a tentative title for a next talk, maybe in November. It's a work in progress. His tentative title is Innovation 2030, how, excuse me, how key technologies like generative AI will shape business in 2030. So keep your eyes open for that. I apologize, allergies here, sorry.
The pollen count is high today. It's all right. Thank you so much. I think this really filled in a lot of knowledge gaps for people. I think what I'm going to take from this is that there are some aspects of AI that seem to be working out really well. There are others that seem like they need some wrangling, maybe some fine tuning, and as you mentioned, perhaps some regulation to keep us all in safe hands and free of the actions of bad actors. So I think that we will be talking about this for a very long time to come, and I think that this will be something sort of on the top of a lot of our minds as we move forward in the immediate future. So thank you so much for sharing sort of this 30,000 feet look at how, AI and ChatGPT are sort of, cornering the market on all things new and chatworthy. So Please stay tuned for more information about that webinar coming up with Michael Connor. That's TBD, but we will make sure that we push that out to everyone interested. And a recording, just a reminder, of this presentation will be available on our website later today. So you can see this and any other webinar presentation we've put out at alumlc.org/MiamiOH. Thank you so much, John Femiani and Jim Kiper. We are happy to have had you today. Thank you all for joining us at home, and love and honor. Have a great day.
Thanks.